this one's knocked about. They only give us the rubbish that they don't need anymore. It's hollow to make it lighter, but it's aluminium. It's also very strong, so it can put up with a lot of concrete weight against it. But you get a really smooth finish. This one's not, but before they throw them out, they're very smooth finish, right? And they're really cool because when they finish with it, they chop it into bits to give it to universities and schools to let them know what they're doing. Now, whenever you see precast, remember when you may not remember, but when we looked at the stuff down on the site, we said if you have a close look, the edges are never perfectly right angled. They're always kind of aristoff, they're kind of like, they just don't do it. Even phones, things like this, they don't do them perfectly square because they just chip and break and all that sort of stuff. They're always a bit rounded. But this stuff here isn't rounded, it comes along and there's a sort of 45-degree angle on every corner. That's how precast goes. Now, the way they get that 45% angle is you have a look here. This is the formwork. It's sitting on the pouring bed. You can see the same here, right? The concrete gets poured in here. It doesn't move. I'm just trying to show everybody and make movies look a bit more interesting, right? So the concrete's poured up to here, and these things here form the arist edges, because you can see there it comes out with that 45 degrees, and then the surface is up here. Now, notice how the surface is kind of rough here. It's just quite bright blue there, but it's kind of rough along here. The reason for that is there's one of these on one side, one of these on the other, all the way around, obviously. But I don't know whether we got the photo up there. I'm sure Andres would have showed you during the production. Oh yeah, right. He would have showed you during the presentation there. The way they level it off in most cases, it looks kind of weird, but they just pull the screening board along, and the screening board has a motor on it, and they just pull that along, and the motor started up, and it vibrates, and it brings the smooth water and cement to the top. If they overdo it, it can mess the quality up. But if they get it right, they get an incredibly beautiful finish right across the top. And this is just all scratched from where they've pulled that thing along. I don't know, it's in the slide somewhere, you guys will find it. You can see two guys from one of the most high-tech forms of construction, and here they are finishing it off by two guys pulling ropes with a bit of timber and a machine on top of it. It's kind of weird. But there it is there, in this photo up on the right. So there's two guys, they got the rope, they're pulling it across, they poured the concrete on the bed, up on the top right photo, and then they just pull that thing along, start the motor up, and that's it. Then they come back later with the helicopter here and finish it off. I don't know how they do it, but as they do it, they always mess it up because it's got to be semi-dry, but they always manage to get it perfect. Precast is the highest quality of concrete you ever get to see. Really, really good quality. So that's just a little bit pieces on that. Now, anyone remember what these things are for inside? He told you about half an hour ago.
Reinforcement and the concrete.
Sorry?
Reinforcement and the concrete.
It's to hold the reinforcement bar and make a connection. So when they put this in, and this is a big one, and we'll talk about the difference in a minute. They put this in the slab, and the whole idea of it, it'll be positioned so that one end of it will be up against, let's say you've got that bit of formwork going down there and this bit of formwork going along here, which wouldn't work because they're different sizes, but imagine they're the same size. That thing would go on the corner like this, right? So you've got formwork there and formwork there. You pour the concrete, take these things off. Now you've got a big slab of concrete and these things stuck in it. Now when they lift it up, zip, right, all they're going to see on the surface is this ugly looking plaster. That's to stop concrete getting in it while you're pouring it, because if it gets in, it defeats its purpose. So that would be covered as well. They cut that open. So now you end up with a hole in the bottom when you lift it up, a hole in the bottom of the precast panel and a hole in the side of the precast panel. Hole in the bottom, as you said, you get starter bars sticking out of whatever you're sitting on, and that's going to be one or two things. It's going to be a footing in the ground, or strip footing, or it's going to be board piers, and they set it up on either side, right? So this thing will have, whether it's a footing or whether it's a board pier, they'll either pour it with starter bars sticking up, or they'll drill starter bars into it later. So you get this thing sticking up. So when they lift the precast slab, they lift it so that the holes in the slab just line up with the reinforcement bars, and then and it's down. And now you've got this hole. Anyone know what that hole's for? Mortar, exactly. So there's movement. So if the slab's slightly out, if you want to get the panels straight, you've got scope for movement in two directions to get them lined up. And they're pretty darn heavy. So when they're lined up, they just fill this up with mortar. And the last bit of the mortar is kind of like dry mortar, because otherwise just pour it out again. And that's pretty much it. Once it sets, it ain't going anywhere, right? So that's what these things are for. Now, how do they position these? Could you pass me those two that are the same line down? No, yeah, that one, yep. And the other one? These are special support chairs for these things here. So they position them with like this, but they always, whoops, wrong way. They always tie them to reinforcement. So they sit on these chairs, and then they will tie them to the reinforcement so they don't move with a piece of wire. You got the idea? And these things here, what's good about them is they act for, it doesn't matter what size the thing is. Now, why would you use this one as opposed to that one? These are used primarily if you're going to be just putting a wall up, particularly you see a lot of these in single wall panels, 1 or 2 stories high, where you need to stop it moving at the bottom, etc. These you're more like to see in precast shear walls, where you're putting one panel on top of the other, on top of the other, on top of the other. So this just, it's going to be a thicker panel, as you can see here. But notice this one's sealed. So the advantage of that one is they can cut that off wherever they want it, depending on the thickness of the precast. If it's a shear wall, the panel could be that thick. You know, it could be really thick. And that's for the same reason as this. It's just doesn't let it in, you have to cut it after, right? But this is a bit of a pain in the backside, to be honest, because if you have a look at that really closely, it's not flat, it's got a kind of a bulb in it. So they never sit exactly. So most of the time, they'll cut that off anyway to get a much smoother edge because of that roundness that's there. You got it? And these grooves, what do you reckon they're for? 2 reasons.
Vibration and movement.
Yeah, they form a better grip with the concrete, the same as reinforcement like this stuff. This is called deformed bars. We'll look at them in a minute. So because the concrete gets into the grooves, and particularly if you vibrate it, gets a really good grip. That's one. The second reason is when you're using it to set it up in the formwork, etc., these grooves give it more rigidity. It's harder to move and bend it. And you've got guys walking all over the steel. So this prevents it bending when they're walking. So it's got 2 purposes. But these things here, exactly the same purpose as this. Now these things here are made by the factory. These are made by someone else who sell them to the factory. And these are quite expensive, right? These aren't expensive. This is just a standard piece of post-tensioning ductwork that they've got a standard Bunnings piece of 45-degree end on a 50mm pipe, and they just go whack, put it together and save money. And then they probably charge you the price for this one. Got to make a profit if you're in business. So that's what they're for, that's what that's for. Let's go through the rest of our toys here and show you what they're all about. Because some of these things you would have seen in photographs, but you don't really get, and I think it's really useful to understand the depth of some of this stuff, what it's really all about? This,
Microphone.
oh, I threw it away, did I? Sorry, Mike. Sorry, my friend Michael. Right. It's really just for the recording. Now, I didn't bring this one. I know what it is, but I don't know what it's got to do with precast. Do you know what that is?
I just bring it for the next lecture.
Oh, okay.
That's post tensioning.
Yeah, post-tensioning wires. But also they can use this for drainage. It's basically double post-tensioning wire, which we'll do later. But also they use this sort of stuff, put in the soil with a lot of rocks over it, and it acts as a, sort of a drainage thing as well. It's got multiple purposes. Now, do you know what those things are? Bar chairs, yeah, well done. What do you notice different about them? It's all in the legs. Can you just give me a couple of different ones? Yeah. So this one here is a mesh bar chair. You'll notice that it's got little bits of grey plastic on the bottom of it. There are two reasons for the grey plastic. Does anyone know what they are? Or could guess?
Prevent rust. Prevent rust.
Yeah, you're right. One of them is to prevent rust, right? That's the main thing, to prevent rust. Now, if this is going to be used in a upper level floor situation, it also serves that when you remove the formwork, you get, one, you don't get rust coming through, and what colour does that grey look a little bit like? Don't say my face, it's very upsetting when you say my face.
Yes.
What? Yeah, same colour as concrete. So when these things are spread around on the floor, the plastic doesn't show up, the colour's the same as the concrete, nobody notices it, right? And that just supports mesh. So you don't see a lot of these days around, but I saw that one somewhere. And for some reason it just jumped into my bag. Does anyone know why this one, by the way, these are double. These allow bars to go in two directions and still be held in by the bar chair. See that? Kind of clever. A lot of people don't like them because if you walk on top, which they do, they kind of move a bit. But generally speaking, it's not bad, and it's pretty easy just to put a bit of wire around it if you have to. But it saves that back bending stuff where you're bending over, tying wires and all that sort of stuff. Okay. Why has this one got a full circle thing on it, and all these have got four legs? What do you reckon? This will make you think. I'll give you a hint. Go back to understanding buildings type construction.
You can rotate to the direction you want.
Not a bad answer actually, because you can, yeah. What are we talking about when you're pouring concrete onto the ground? What do we say is a good thing to do? Like pouring a driveway for a house or something. One or two things. You either got to soak it, really soak it well with water, or put waterproofing down, put plastic down. Now if you put something down with plastic, with legs like this, and you get 3 or 4 big fat guys like me walking around on top of the reinforcement, what's likely to happen with these legs? Straight through the plastic, and the waterproofing's gone. But with this thing, da 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 da. What they used to do is they used to get little tin and plastic plates. They just looked like, in fact, quite often they used to use the lids off a paint tin. Do you know the lid in the paint tin's got a little groove on the side of it? Builders would save those and they'd take them to the next job and they'd put them on top of the plastic and sit that on top of those because it spread the load and it wouldn't penetrate the plastic. Then someone said, why should the paint tin people be not getting paid when I can get paid? So they come up with the idea of creating this built-in load distributor. So instead of having a point load, you're distributing the load, it won't go through the plastic. Got the idea? Isn't it a wonderful profession, construction? So many good toys. I presume you already know that this is what they call a deformed bar. This here has got what I would call an okay level of rust on it. But if it goes much beyond that, it turns into scale. Scale is where the rust can be lifted off with a screwdriver or something. That's no good, because when the water it'll just create a little bit of oxygen is all you need with that water to make the rust work. It'll pop off and cause concrete cancer. This one is also a deformed bar, but it's much more softly deformed. And this one is a mild steel bar. It's just a standard bar with no deformation. So it's got a very light roll in reinforcing. So you can play with those. I'll give you all time to pass them around in a minute. This is the same as that. This is what we call ferrules. You've heard us talk about ferrules a couple of times now, and I think Andres would have mentioned in that last session as well. So ferrules, they're basically a reinforcement bar connected to a fitting. And these things have to be put 100% accurately. Can I have, I think it's a blue one, mate. I might be wrong, but I think it's a blue one. Let's try the green. There we go. So these things is that thing there. It's a slightly different fitting. This one here is used on the, this is particularly used when you want to connect a floor slab or something like that into the wall. Andre showed you earlier on the groove with these holes in them. So what happens is this one's a bit screwed up. Let's try that one there. So these things screw in, and it's misaligned. It's the actual plastic. They should go in really evenly. I don't think I've got a spare green one, but just imagine it's gone in evenly. In fact, I'll show you here. So see how that one there looks really parallel there and parallel there? That's how this is supposed to be. But obviously it's not. Let's presume it is. Oh, that worked. Do not play up in class. This guy is very strong. No, I think it was ready to be buried. It's had it, right? But you get the idea. So what happens normally is if you want to screw something at the top end, this will simply go down. So it'll be put on the edge, because keep in mind you're going to pour it on the flat. This is the slab, and then you're going to lift it up, right? Or the panel. So if you want something to connect at the top, one panel to another panel or whatever, you wouldn't probably do that. But let's say you're going to, it would go in straight with this thing very, very even at the top. And that's because you're getting one of these things that would be, if you have a look at these things, they have little holes there and there. And that's on the other side, they're holes. That's because they nail that or screw it to the formwork. So once it's nailed or screwed to the formwork, if the formwork is absolutely perpendicular, then this thing will be absolutely perpendicular when you take the formwork off. So what happens then, depending on which direction this goes, we'll worry about that later, whatever you've got a bolt to, you just bolt it to here. Now later on we're going to be talking about tilt panels, and tilt panels are held together by what we call stitch plates, where you have two panels fixed at the bottom, but at the top they might be out of alignment. So they put these ferrules in them towards the edge of the plate. They put a steel plate across them, and they bolt the steel two plates, and they hold each other straight, okay? Now when that happens, you can't have it like that, because you've got the thickness of the panel, and this would be sticking out the other side. So they put this in, and they bend this down inside the panel. So you've lifted the panel up, you want this on the face, so you can put the steel plate and tie it into position. So they have to turn the reinforcement down, and they have to tie the reinforcement in with the reinforcement that's designed for the panel to get the strength that they need, right? And you'll see that when we get to one of our next subjects. So that's what it's ferrule, F-E-R-R-U-L-E, as opposed to feral, F-E-R-A-L, like a stray cat is feral. English is weird. Same words, different meanings and all that sort of stuff. So you can muck around with those. Now let's look at some other bar chairs. Can I steal that little one you got there? Now this one here is quite different from the others. If you look at this one, once again, You can fit you can see the two different levels. I'm using reinforcing fingers instead of reinforcing bars, right? But they still are designed so you can get them crossing over in the chair. You'd still have to tie these ones because otherwise they just bounce around and get out, whereas these things have the grippers built in. Now this one here, once again, you sit it down, make sure you get the amount of cover. You can get these in different leg lengths, and the leg lengths define how much concrete cover they want and how thick the slab is going to be. Now this one's more likely to be on a ground floor, I think, on the ground, or on a rough sort of finish, because look at the amount of chair that's going to be showing out through the bottom of the concrete. See the area of that? But if we take a look at this one, they have changed that from being a large cross-sectional area, which gives it strength, to moving from a relatively large cross-sectional area. And if you have a really close look, they're just like little round things on the bottom. So when you put it in touch with the ground, it's like you've just got a tangential touch on the surface. It's like having a circle with a line drawn across the top. It just theoretically touches at one point. So if you have a close look at that, this is for slabs, and keep in mind that that distance there is about the concrete cover on the bottom reinforcement. So this is used on suspended slabs, so when you strip the formwork you can't even see where the bar chairs were because these points are so small. Okay, so have a look at that and pass it around. This one here I was demonstrating the strength of this particular type of bar chair, and then I found out it wasn't quite strong enough to support a fat bloke like me, so the leg broke off. So it's not a three-legged bar chair, it's a four-legged one that did not sustain my weight. Put in the terms of this classroom, the downward force was not able to be resisted by the upward resistance of the plastic, right? Here's another one of those little ones, a different colour for a different colour concrete. You can see, again, you've got the grips in both directions, start going around the other way, but you can see that the circle then means that you can hardly see it when you remove the formwork. Now these things here are in precast. They do it slightly different in precast. There are a zillion things that can fit into this in precast. One of those zillion things would be this here, okay? Your job, can you just put that in there for me while I talk about other things? These things here work together, but we'll just wait till she gets this together.
How?
It keeps falling out of the bottom. It's supposed to be held tight. So now you've got the screw component inside the supporting component. Have a look at the picture. That's how it's supposed to look. Look, can you pass me my pointer? Thank you. So it's supposed to look that here's the legs resting on the bottom and the blue bit's supposed to come out the top. You've created a new modern version of it. I think the old version was better. Oh, well done. That's a lot quicker than most people. We always throw it to someone and say, oh, could you do this for us? Some people are still going half an hour later. It really can be quite hard to put those together. And if you're trying to, did you go in from the bottom or the top?
From the bottom.
Yeah, the bottom. If you do it from the bottom, it's quite quick. If you do it from the top, it'll take you forever. But when they go together, you get the effect that it shows in the picture graph. So you've got minimal points coming through the concrete, right? Those are hardly seeable. That sits on the formation thing, in other words, the formwork in the factory. This thing is aligned exactly the same height as that's probably a different one, it is. It's not the same height, unfortunately, but this would be with a bit of formwork that would finish off exactly at that level there, right? And then, typically, they will put a lump of reinforcement through here. That one's not going to fit, and they'll have to be the right size. And that reinforcement will be bent to tie in with the structural reinforcement in the slab. Where's Andres? Mate, did you mention about putting the extra Rio around the edge for lifting and all that when you did precast?
No.
Okay. When they do a precast panel, there's three things that make precast panels expensive, apart from the fact it's quality and all that sort of stuff. And the three things are, I don't know whether you'll see it there, you might. Yeah, there you go, that'll do. See where he's pointing out, that edge. So this is the main reinforcement you can see there, but if you watch the arrow, that's around the edge. And then, stop there mate, up the top here with the lifting connection. What you're looking there is the lifting connection tied into the reinforcement with that big circular bar. So they can't afford to have a slab sitting in the factory for 7 days waiting to cure. They'd go broke. So they have to form it, pour it, reinforce it, pour it, and they pretty much start work 6 o'clock in the morning. They're gone home by 12, 1 o'clock, right? And they come back in at next 5 or 6. They then have to lift that bit of concrete. Now, if you tried that with a normal bit of concrete and you went to lift it, all you would get is reinforcement ripping out of the concrete. But the reason precast costs so much, it saves a fortune in time, but in terms of its cost of product, you have to use an accelerator to make the concrete set quickly. You have to use high strength concrete because if you want, say, 32 MPa concrete, you're probably going at 48 or even up to 60 MPa concrete, because after 1 day, even with an accelerator, if you use 48, you might get 30, right? So it's really about the strength you achieve in 24 hours. So that makes it expensive. The third thing that makes it expensive is you've got to be able to lift this up and put it in the drying racks without the componentry being pulled out of the concrete, because the concrete's only 1 day old. So what they have to do is what Andres was pointing out before when he was going around the edge. You would have seen an additional row of reinforcement all around the edge. You can see that one there is a great photo up the top, mate, on the corner. See that big thick bar going across and then across the top? The only reason for that bar is to give it the strength to be able to be lifted 1 day after. So you've got high strength concrete, accelerator to make it set quickly, and some seriously heavyweight reinforcement in there. Have a look at the reinforcement in the middle that's holding the panel together. It's pretty skinny stuff, right? But then, you know, you've got that quite heavyweight stuff around the boundary to hold it together when they lift it up. A lot of tensile forces going on when they lift it. So that's what reinforcement is expensive for. This one here, held in place, undo that, and whatever's going to attach to the panel. I think Andres showed you the photo of the slab or the precast panel that had a slab connection point in it. And that slab connection point, I think he's going to show it now, was where you can see them there in the side. That's another one. They use them everywhere, these ferrules. This is on a precast flooring panel. But they're the same thing, ferrules. Okay. These things here are lifting lugs. They fit in the same sort of thing as this. Once again, they're all basically the same on them, fit in there. So these lifting lugs are always in the side. These are mainly used for tilt up. We're not going to have a look here. So these are just what the ferrules look like when you screw that thing out. And normally they fill it up with Vaseline, you know, petroleum product, Vaseline that you can get at the chemist and all that, and put them on babies to stop nappy rash and all that stuff. Basically, if this thing fails and the concrete gets in, then the Vaseline stops it causing any problem, because it's kind of like a waterproofing. But if you do a whole panel and one of these gets full of concrete, you've got to throw that panel away, man, because you're not going to be able to bolt to anything. Concrete won't come out. If you try to get it out, it'll strip the screw thread in the middle. Okay? Now, so this is a floor slab going to go in there. So what are these things for? Do you remember what he told you? It might be hard to remember. It must be at least 45 minutes since he told you. What are they for? Let me think, what did Andre say 5 minutes ago?
For stairs, you mentioned stairs,
Yeah.
stairs rolls.
It could be stairs, it could be a stair fitting, but I don't think this one is. It might be, who knows? It depends on where it goes. But I'm talking about even if it was stairs, how you connect it up. So that's a ferrule, that's these things, right? They screw the starter bars into the ferrule. I don't know what this is, it's hard to tell just looking at it, but let's presume it was some piece of building element, looks a bit Kong-me to me,
Yes.
that a floor slab is going to be connected to, or some other panel is going to be connected to. The starter bar goes in there, the formwork gets up here, and then where they pour it, this becomes a support piece for the connection of the floor slab or whatever it might be to this. That's probably a vertical element. Okay. Did you show them the one made of the column that went across 2 stories and they had the steel supporting it? I'm not sure if that's in this section or in the tilt panel one.
Maybe this will find it.
No, I think it's in tilt panel. They're very similar. Don't worry if you can't find it. But anyway, that's a couple of those bits. These lifting lugs, as I said, they come in all sizes. So here we have a nuclear family, dad, mum and 2 kids. So they can be for all different sizes of panels. They all fit it, they get held together with these sort of things. They're on the edge and they typically will have a groove behind them because when they want to lift the stuff, these things, they want it to be in the surface so they can put the hook around it, but they don't want it sticking up above the surface. Because these things are typically used for tilt panels. We're going to talk about tilt panel later today, tomorrow. But when you do tilt panels, so that lifting lug thing there, you're sort of connecting. So see how they've recessed? They're recessed. That's because when they make, not so much for these type of panels, they're made in a great big straight line. But if you're using tilt panels, you can't have this sticking out the top because the way you build tilt panels is you pour one, and then you put a bond breaker, which is a material to stop concrete sticking to it. Then you pour it on top. Then you put another bond breaker. So you can pour these panels one on top of the other. But if you've got these things sticking up, you can't pour them on top of each other because it'll fix them all together. So this has to be buried down within the surface of it. Okay. So they have to put it down and they have to have it covered so that it won't affect the following slab. Anyone know what this is? No? It's a lifting device. This fits inside the slab. So you've got a wall panel here. This would be a fairly narrow wall panel. I'll show you a seriously thick one in a minute. So this will fit up against, and there's a fitting which I'll show you in a minute, up against the formwork. Formwork strip, connect, sorry to wake you up. The hook goes in here and then they can lift it up and lift it up to put it into position. And this here is to get really good grip on the concrete, and also they put some reinforcement bars through here as well on the way down. But that's a pretty decent grip if the concrete's put in. But by far the more powerful one on this one is this thing here. That's a serious Jaws piece of equipment. And that fits to this thing here. And this one's been used, which is why it looks so ugly. Now the way this works, these things here, you can see on the side there, there's had a couple of screws through it. See the hole there and a hole there? That gets bolted to the formwork or screwed to the formwork or ramsetted to the formwork, but it fits like that. And then previously we showed you the reinforcement coming through there. This one hole here is for that big serious piece of reinforcement. See the gizmo there? This guy doesn't trust the engineer, so he's actually bent the legs around in 2 directions to get even better grip. But you can see up the top, that bit of ugly rubber is the same as this one. I'll show you why it's there in a minute. This one here is so you can put a lump of steel through and bend it over like they have there to tie into the reinforcement, right? so that when you strip the formwork off, actually the other way, of course that would not strip that way, you see this here. See how the edge there is kind of rough? That's because they put a chisel or a screwdriver in there and they lever this up. They throw that away so that people like me can go and pinch it and teach students. And then you end up with a hole in a groove. The reason for this is now you still have, if this was the panel here, you still have a perfect edge to the panel without the lifting device sticking out. Because if you've got the lifting device sticking out, you can't put the formwork in place. So this was a very clever way of making sure you could expose the lifting device in the panel, but still keep a perfectly smooth edge so you connect panel on top of each other. Okay? So the crane hook goes in here. That's what it looks like there. We looked at it in the first intensive. We went down and had a look at those groovy things on those panels where old Hawkeye over here picked up that the panels weren't straight on top, and on the side they had some of these. But that's what they looked like. See the blue coating there? That's the blue there. And the hook goes in there, but none of that sticks up above the edge. So you can put one panel on top of the other, on top of the other. Okay? What else have we got to do? Most of these are just ferrules. Make sure I tell you what they are. This is just connecting pieces. This can be used on a thin slab, typically a tilt-up one, where you have a ferrule on one side and a ferrule on the other side. So this turns into being a ferrule, and it works. Forget that we've got steel on the end of it. So they would simply use this to tie in with the general reinforcement, and this thing would be lined up with a plug or screw plug on either end. And when they lift the panel, you've got a connection on both sides. And quite often that's used in thinner, tilt panels are often thinner than precast, right? And quite often that's used to do stitching plates on either side. We'll go through that today or tomorrow. Everyone got the idea? So these bits and pieces are all part of the precast thing. Do you know what these are for? Anyone guess? This is how Andres does his exercise. Now this is for joining, because normally if you want to join reinforcement, you have to overlap it. The engineer will say if you can't get the reinforcement in one length, you have to overlap it, and they always tell you how far to overlap it in diameters. They'll say overlap it by 30 diameters or something like that. So you overlap it by that distance and they tie it together. Then some genius come up with the idea that for bigger steel in particular, you know, it gets a bit wasteful for these great big overlaps and they take too much space. So you just screw them into there and screw them into there, and that becomes effectively makes it into one continuous piece of steel. Okay, so there's big connectors. I don't think there's anything else. Oh, there's two other things. Anyone know what these are? We haven't covered them yet.
Sim pad.
So you can go when the band's playing. Sorry, what was that?
Oh, the shin pad.
Yeah, they are. You're right. They're shim pads. Did you cover shim pads? Did you?
Not yet.
You're sounding like a genius, isn't he? Yeah, shim pads. So these are high density plastic materials, and every colour is a different colour. I used to be able to tell you the thickness. Every colour is a different colour. Every colour is a different thickness, right? So they go from like a couple of millimeters thick through to, you know, a little bit thicker than that. And by measuring or laser differencing, the difference along, and the reason for this is most of these things are in the ground. This one's obviously been formed up and they've done a good job of it. This one here happens to be, anyone ever go shopping at Coles at, the corner of Ashmore Road and I forget the name of the street. Shopping centre that's over in Benoa, but not the one up on the hill, one down, but at Coles Benoa. It's where the Vantage apartments are, and there's a Coles shopping centre right next to them. Sorry?
treetops or they? Or
No, not
are
treetops.
they all-
It's quite close actually. It's only about 5 minutes drive from here, 10 minutes drive. But anyway, this was here. It was built by Hutchinson's, and in those days we didn't have really big classes, so we used to go out and have a look. So this was actually a ground beam that they'd done, and that was supporting the precast panels. And you can see it was very well done too. You can see they put a groove in here, or a grade, so that the outer level is higher than the inner level, which means if water gets in under the panel, it'll be stopped at that point there, and their internal waterproofing was fitted to that as well. So they've got a blue bit and a grey bit. The blue one's a really, really skinny one. So they've got blue, black and white. And they tape them together. You might think the tape adds a bit of thickness, but trust me, when you put 20 tonne of concrete on top of that, the tape just goes and squishes, so you don't have to worry about that. Whereas these are quite resistant to that. So a few things you can see here. First of all, you can see a hole that's been drilled for a starter bar to be put in, which it hasn't happened yet. That would have been made by just putting a little bit of polystyrene foam in, and they just cut the foam out later. So they'll put the starter bar in there before they lift it. The guy who did this, Jeff, project manager, you'll see photos of him later. He actually just put those in place to show us. And you only put them at either end, because these big precast or tilt panel, when you use it in a walling, it acts as a beam. So you never put 3 supporting panel pieces, never, unless the engineer says. Because it's designed to just span between 2 points or rest on the footing. Normally they'll rest it on 2 points though. And you can get all different thicknesses by, I think there's about 8 different thicknesses of these, but by combining the colours you can cover just about everything from 5 millimetres to like 70 millimetres difference. And they just tape them together. So that, we'll leave these out over lunch. Please don't, souvenir them, because we used to have 14 bags of these things. Now we've only got 1 bag left. That's a bit